Some things I'm involved on campus is that I'm president of Pacific Club. I'm also a graduate teaching assistant currently this semester and also work as an ambassador with everyone else. And I'm also the financial officer for the electrical and computer engineering outreach team.
Hi everyone, my name is Ananya. I'm in my third year studying chemical and biological engineering. My pronouns are she, her, and hers, and some of the activities that I'm involved in on campus are that I'm in the University Honors Program, like Ethan and Sammy. Apart from that, I'm also participating in 2 different undergraduate research labs on campus. I'm also in AICHE, which is the American Institute of Chemical Engineers, and in the CSU chapter for Engineers Without Borders as well.
Wow, and I'm Sammy. I'm in my 4th and final year studying civil engineering. I'm from Centennial, Colorado, which is just south of Denver. And on campus, I'm involved also in the honors program. Like Ananya mentioned, I get to be an honors chair mentor and teach a class for honors students. I work as an engineering student ambassador. I'm the secretary for the Society of Women Engineers. I'm involved in a campus ministry, and I also just like to have some free time to do fun stuff. And we do have one more ambassador in the call that I definitely don't want to gloss over. It's Katie. She's here for tech support, so she'll kind of be in the background helping out if we have any technical issues. But just so you know that she's there, Katie, do you want to quickly introduce yourself?
Yeah, for sure. Hi, everyone. My name's Katie. I'm a 5th year studying chemical and biological engineering with biomedical engineering. And yeah, I'll just be hanging out. So if I feel compelled to give my experience, I'll just be hanging out in the chat. So yeah.
Sweet. And just to preface, throughout this tour, we would love to have some engagement from all of you. So if you have any questions that pop up as we're going through these slides, feel free to throw those in the chat and we'll try and answer them in a timely manner. But we'll go ahead and get started. So welcome to campus. This is campus facing west. For those of you who aren't from Colorado, the mountains are always to the west, so it's a really easy way to know your way around. We have the foothills probably about 15 minutes away. There's tons of hiking and biking and water sports at Horsetooth Reservoir. And I don't know if y'all can see it, but the flagpole in the foreground on the left, just to the right of that, about midway through, is kind of a weird shaped rock called Horsetooth. That is one of my favorite hikes in town. It's about 6 miles up to the top of this rock. Gives you a beautiful view of CSU's campus and the rest of Fort Collins to the east, and then the mountain range and Rocky Mountain National Park to the west. So if you're coming out to visit Fort Collins at any point, or maybe when you get here in the fall, definitely make it a priority to do that hike. Other than that, as you can see, there's lots of green spaces, beautiful mountains, beautiful trees, and lots of bikes, and it's very sunny. We get 300 days of sunshine a year here in Colorado. So students really just enjoy to be outside, and it's a really welcoming environment. All right, these are a couple aerial photos just to give you a better view of campus. So the top left is looking down on our intramural fields, and you see that little pond. That is the lagoon that has been recently renovated. There's a nice little forest right next to that where you can set up your hammock and read a book, or you can play Frisbee with your friends. There's a pretty good sledding hill right there. And then the 2 main buildings that you see are the Laurie Student Center with the big white roof. And then to the left of that is the engineering building, which we'll zoom on in a bit. And then the bottom right photo shows our beautiful football stadium, which was new to me when I was a freshman 3.5 years ago. So fall of 2017, I believe, is when it opened. And we totally crushed the opposing team in our first game, which was really fun. So if you have a chance to go to an in-person football game when things are back to normal, it's super fun. The construction area that you see on the bottom left is going to be a brand new residence hall. I'm not sure when that's supposed to open up, but it is currently under construction. And then to the right, on the very right edge of the photo, you'll see some nice brown, reddish, and white buildings. And that is also a residence hall called Academic Village. The one in the photo, I believe, is Aspen, but we'll talk a little bit more about the engineering residential learning community if you haven't heard about it yet. And then to tour our Scott Bioengineering building, I'm going to pass it off to Kylie.
Awesome. So let's kind of get kicked off. Before I kind of go more in depth into the tour, I will have to say you will see pictures throughout this entire presentation of people who are not social distancing or not wearing masks. And that's just because those pictures were taken before COVID kind of started. So just so that you're aware, campus kind of looks a little bit different now, a little bit. And as Sammy was saying, we really do want to see a lot of engagement. So if you do have any questions, drop it in the chat. But in the meantime, if you could let us know what your majors of interest are, that way, as we're kind of going through the tour, we can kind of get a sense of what students have more interest in different types of majors, or if we have a major that has no interest at all, kind of a thing. So just let us know so we can try to personalize it as much as possible. But besides that, yeah, let's kind of head on into Scott Bioengineering anyway. Cool. So when you start and you first walk in, on your left-hand side is the Engineering Success Center. The Success Center houses a lot of awesome resources specific to students in the College of Engineering. It's where us ambassadors have our office, although we're not really in there right now. But the Success Center is different because typically there's an all university success center, but it's really nice because within the College of Engineering, we also have an engineering specific success center. And that's just because when you're looking at like professional development, an engineering resume can look really different than like a political science resume. And so what is offered through the Engineering Success Center is a lot of different organizations and professional development. The first thing I like to talk about is kind of a few workshops that are available. So they offer like resume reviews, mock interviews, and also LinkedIn workshops. These are really great resources for students because as you're kind of starting to get ready to enter the professional industry, you want to make sure that you're presenting yourself as well as possible. And so getting someone to kind of look at your resume again, or getting tips and pointers on certain ways to like introduce yourself to an interviewer can really help make people can really help put you at the top of someone's list, kind of an idea. The Engineering Success Center also houses our, I guess, semesterly career fair. Our career fair houses dozens of recruiters every semester, and they try to get at least 10 companies representing every major within the College of Engineering. And it's really nice because whether you're looking for a summer internship or even an entry-level starting position once you graduate, there's always going to be something for you at the Engineering Success Center or at the career fair. Besides that, there are also some organizations through this center as well. So if you're looking at diversity programs in engineering, such as SWE, which is Society of Women in Engineers, which Sammy is a part of, or we have SHIP, which is the Society of Hispanic Professional Engineers. So there's a lot of amazing resources located in this Success Center for students. So now heading up to the second floor of the Scott Biomedical Engineering building, we'll talk a little bit about resources available to students before we kind of get into the more academic like lab spaces. This is the Cassini Design Studio. It's donated by Lockheed Martin. Perhaps you've heard of them. And I really like talking about this room specifically because it really showcases one of the really big points of the College of Engineering, which is collaboration. You'll hear us talking about it a lot throughout this tour. But the idea behind it is this room actually mimics the workspaces you'll find at Lockheed Martin or a lot of industry standards. And so the idea behind it is you have a room where you have individual workspaces around the perimeter, and in the center you'll have like a really big table for collaboration. So maybe at the start of your day you'll meet together at the table, talk about what needs to be done, and then you'll break off into your individual workspaces, get some work done, and maybe at the middle of the day or at the end of the day you'll come back together and talk about the progress you've made. My favorite analogy is the rocket analogy, and it's that no one engineer is ever going to solve any problem in our life, right? And even if you're looking at trying to build a rocket, you have a lot of different engineers that go into building a successful rocket. So you could have a mechanical engineer build the body of a rocket, but an electrical and computer engineering student might look at the controls or the computers within the rocket. Civil and environmental engineering students might look at how to build the platform of the rocket and where to launch the rocket from. Biomedical engineering students might look at the livability of a rocket, trying to see if you're launching an astronaut into space. Civil or chemical and biological engineering students might be looking at the fuels for the rocket. So this is a really awesome example of how you can have one problem, which is building this rocket, but so many different views and ideas have to go into building this rocket that really any major can focus on any problem. It's just different aspects of that problem. A few other things to note is that in this room, you also see any computer located within any of the 3 buildings that we'll talk about today. Are offered through our engineering technology services. And so this will be separate from other computers you'll find on campus, where you'll be given your own login, and you'll have access to any software that you might need for homeworks or labs so that you can complete them. You'll also get printing credit every semester. So I normally tell students, like, it's not worth it to bring a printer if you can avoid it, because you'll definitely, anywhere you see a computer, you'll always see a printer. Another software offered on these computers, which is really helpful, is remote desktop, that basically allows you to access these lab computers from your personal computer at home or something like that. So maybe it's really cold and you just forgot to like send yourself a file from the lab computer. You can easily just remote desktop onto there and email yourself that file from your own computer rather than having to go all the way to campus. Cool. And this is just across the hall looking at a different type of study room. This is a really cool room because there's a whiteboard wall in these types of little study coves, but be careful because not every wall in this building is a whiteboard wall, so don't just like start randomly drawing everywhere. But it's really cool because this picture you can also see in that kind of red wall, there's more of those study rooms similar to how we saw in the Cassini design studio. So there's a lot of spaces available to for students to like study or get together and work on a project or something like that. And now back to Sammy.
All right, so like I said, I'm a civil engineering major, which is in the Department of Civil and Environmental Engineering. And this is an environmental engineering lab that I really wish I get to take as a civil engineer, but maybe I will if I continue on to graduate studies at CSU. But water is a huge aspect of civil and environmental engineering. And for environmental engineering specifically, they're really interested in water quality. One of our other ambassadors named Katie, who you may have met this week, is an environmental engineer, and her story of how she chose her major is she was doing some service projects internationally. And while she was working in the community, she drank water that was not very well treated, and she got a really bad waterborne illness. And so therefore, her kind of life goal is to help to prevent these waterborne illnesses in places that are so susceptible to them. And I think about a third of the world's population lacks access to safely managed water systems, and over half the world lack access to sanitation systems like toilets and like washing hands and showers and all those types of things. So this lab is really pivotal in learning how to treat water, whether that be through filtration, like physical treatment processes, filters, sand, things like that, and chemical processes like, I wish I had taken this class and I could tell you more about it, but there's both of those aspects to treating water, and you really get to get hands-on. There's actually a pipeline that goes directly to the Poudre River that you can access from this lab. So testing the water quality in the Poudre River, which is about 15, 20 minutes north of campus. My senior design project is actually right over there. So there's a lot of really cool things that you get to do in this lab, and really getting into the nitty-gritty details of everything that goes into creating clean drinking water, so that when you turn on your tap in the morning, you can really be certain that what you're about to put in your mouth is safe. And Ananya, our chemical and biological engineer, can tell us a lot about this awesome lab.
Definitely. I'll definitely be biased speaking about this lab, which makes sense because it is my major. But this lab is honestly, as you'll find, a lot of our labs are really great experiences for students to just get more of that hands-on learning from your first year itself. And that's why this lab serves as a great space to do. So sort of before we delve into like the projects that students typically do in this lab, I'd just like to give a brief overview of the program itself. So you'll notice that at a lot of other institutions, you either find a chemical engineering degree or a biological engineering degree. They're often not one program itself. But at CSU, the reason we decided to make them the same program is because chemistry and biology have a ton of overlap. So even if you think of a class like thermodynamics, let's say, That's a class that's typically associated very much with chemical engineering, sort of trying to figure out how heat systems work and things like that. But then there's a huge biological component in that as well. So with the chemical and biological engineering degree, you're able to go into more of those typical chemical engineering fields like gas and oil engineering, industrial, petroleum, anything like that. But then when you add in that biological component, you can also delve deeper into biotechnology and nanotechnology and just go further into that degree as well. So it just gives you a lot more options in terms of career prospects. And the other fun fact about this program as well is that we were the first institution to actually make an Abet accredited chemical and biological engineering program. And so that sounds like a lot, but basically what it is Abet accreditation is basically our engineering accreditation board. So no matter which engineering program you're looking at any institution, you want to make sure that it's Abet certified, because that basically means that professionals in the industry have looked at the program and basically told you that your program prepares students to truly be prepared in the workforce to tackle on problems that those types of engineers typically face. So that's definitely very, very relevant. And the fact that we were the first institution to make that program was incredible, because that's just given us a lot of exposure to the different types of ways that students can be introduced to the sorts of problems that you'll find in industry as well. So that's a lot of technical logistics about the program, but if we actually think about this lab space itself, it's really cool. So the machine that's right on the slide here is actually called a hemodialysis machine. And I'm not sure if any of you are familiar with it, but what it is it essentially acts as an artificial kidney. So let's say your kidneys aren't functioning at optimal level. Their function is typically to filter out waste toxins and just all the gunk out of your bloodstream that you wouldn't typically want in there. And so if your kidneys aren't functioning optimally, you're able to use a hemodialysis machine. And by having this equipment in the lab, students are able to understand not only how that machine works, but also how your body reacts to it. So there's pressure sensors, oxygen sensors, and things like that. So you really understand how all those parameters work within the human body and how you can introduce different things to make sure that you're still able to maintain the body at whatever condition you want to maintain it at. There's also a lot of different ways you can use this machine. So you can get it to mimic heart conditions, so your heart pumping blood around the body and things like that. So it definitely has a lot of applications. And one of my favorite stories that I've heard about this machine actually comes from first-year students. So in that first year for chemical and biological engineers, we take an introduction to chemical and biological engineering class, and it also has a supplemental lab part to it. So in the lab part to it, there's one professor that usually brings his students into the lab, and they usually just see all the wires disconnected or connected to the wrong places. So they'll usually see water spewing everywhere, or just the pressure is not really, the sensor is not really working like they should. And if you're a first-year student and that's your very first experience in lab, on your first day of class especially, that can be very, very overwhelming. And while it just seems random that the professor would just choose to do that, the reason the professor does that is because as an engineer, you're often exposed to problems that you can't necessarily know the solution for. And that's what engineering is. It involves a lot of critical thinking and problem solving. So especially when you don't know how to solve a problem, you have to rely on your peers, and you have to rely on the knowledge that you're learning from the lecture at the same time to come up with an optimal solution. So by being exposed to that early on, you're immediately thinking more in that engineering mindset, and that prepares you for your future years as well. So that's just a really cool thing and one of my favorite stories from this lab. Right, and then if we go on to the next slide, the top left picture is just an overview of this lab space itself, and then the bottom right picture has different sorts of equipment we use, like centrifugation machines, things like that. But the main thing that I like to draw your attention to on this slide is actually in the bottom left corner. And so that picture has a couple of machines in orange and white, and what those are bioreactors. So the easiest way to explain bioreactors is, let's say you have a medication that says it's going to work effectively in 10 minutes. And let's say it's supposed to work effectively for your stomach. Using a bioreactor, you can mimic stomach acidity and just stomach conditions in general in that bioreactor. So let's say you create a solution. You can make sure that it's at the right pH and things like that. And then you can introduce that medication, and you can test if that medication's claim is truly accurate. So if it says it's going to work effectively in 10 minutes, you can see if that works. And then you can also take it a step further. So let's say it doesn't work effectively in 10 minutes, you can then see what else you can change in the body. So what other things you can introduce into the bioreactor to make sure that it's working optimally. So it's giving you a lot of that hands-on experience and allowing you to think more about how, again, you might not be exposed to everything, but you sort of have to use your knowledge and think outside of the box to come up with more solutions. So that's just a really great way to experiment with these. A lot of our students also ferment beer in these. And while that might seem really random, Fort Collins actually has a ton of microbreweries. And one of our most famous ones is New Belgium Brewery. And so if any of you have been to Fort Collins, you might have heard of that one. And a lot of our students do internships with New Belgium and then often also go and work for New Belgium afterwards as well. So that's just a really great way to not only work with industry leaders, but also get that exposure to what you'll be doing in a future internship in a lab space itself. So it's just a really great way to get that hands-on experience and build up those skills for those internships that you might not necessarily get in a lab space otherwise. Right. And then I'll turn it over to Ethan for our biomedical engineering part.
Thank you. I apologize for the slide transition. My computer's running a little slow. So this is our biomedical engineering teaching lab. Just a quick overview of our biomedical engineering program. So it is a 5-year program and it's a dual degree program, meaning that you will graduate with a Bachelor of Science in Biomedical Engineering and then a Bachelor of Science in your partnered major. And so you can partner that with mechanical, electrical, or chemical and biological. So I like to think of it as buy one, get one 75% off, basically. And so the reason we have that set up as a 5-year program with a partnered major is because we've heard from industry that biomedical engineering as a major itself cannot give you the depth of knowledge that a lot of industry employers are seeking from different fields. So example, prosthetics would be something that I would work on as mechanical engineering. Something like drug delivery would be something that someone in chemical and biological would be working on. Working on X-ray or imaging technology would be something that an electrical engineering would work on. And so having that background in mechanical engineering helps me understand a lot more of what is necessary to do in those engineering processes, but in a biomedical engineering application. And you may be wondering what I'm losing doing this additional major in biomedical engineering. So I'm actually not losing anything from the mechanical engineering side. So I'm taking all the same classes that my purely mechanical engineering peers are taking, just additional technical electives or biomedical engineering classes, which is why I have that 5th year. And so this lab is a really great, I guess, demonstration of what we like to do in the biomedical engineering field. And so basically, this is a problem-based learning class or lab. So in the lecture, you'll meet for 2 times a week and you'll learn how to approach problems. So you're not necessarily learning about the problem that you're facing. So in this picture, Ananya was our lovely test subject. And so she has these EMG electrodes placed on her forearm. So the problem statement was to identify the best location for EMG electrodes so that you can record individual forearm muscle movements and contractions and convert that into motion into a mechanical prosthetic hand. So in this lab, you work with a group of 4 or 5 people. And what's so cool about it is that because this is in your 3rd year, you're working with chemical and biological engineering students, electrical engineering students, and mechanical engineering students who've already spent 3 years learning about their respective fields. So we're all approaching it from different problems. And like Ananya and Kylie were saying, the problem is never going to be easy enough for you to solve on your own. You're always going to have to work with someone else to get that problem solved. So having those different perspectives from those respective partnered majors is really critical to creating generating a great solution for this class. So for example, with this prosthetic hand, I'd be working on something like designing the mechanical hand and figuring out the linkages and the motor systems for that. Someone who's in the electrical engineering field would work on the signal filtering. So taking those electrical impulses from the forearm and turning that into interpretable signals from the prosthetic hand. And then someone from the chemical and biological side would say, if there's anything that we can do to help increase the signal biologically that's being produced from the person. I also like to talk about in this lab is our research. So CSU is, I don't know, I want to say it's within the top 5 of most funded universities without an attached medical school for research, meaning we're a tier 1 research facility. So that means that basically any professor that you are working with or that is here at CSU has some research that is going on, and they love to have undergraduates working in their lab. So even as an undergraduate, even as a first year student, your first semester, you can get involved in research. And what's great about that is it lets you dip your toes into a lot of different subjects or areas that you might find interesting and see if that's what you want to keep pursuing. And it really just is as easy as just emailing a few professors. So what I did my freshman year is I just went on to the biomedical engineering website, found the research tab, saw what everyone was working on, and then literally just emailed 6 or 7 professors asking, hey, I'm really interested in what you're working on. Do you have any space for an undergraduate to step in? And all of them got back to me within a week and said, we'd love to have you come to our lab and see if you'd like to work here. And so I've been working in the cardiovascular biomechanics lab since sophomore year, and it's just a lot of fun. And so it's super easy to get involved in research here at CSU. Yeah. All right, so kind of transitioning into our engineering building. So the Scott Bioengineering building focuses on a lot of more our biological engineering based labs. And so this is the main engineering building, which houses our the computer and electrical offices, the mechanical engineering offices, and then the civil and environmental engineering offices and related labs. Here's another picture. So this is the engineering manufacturing lab, or the EMEC. This is probably my favorite place on campus and probably where I've spent the most amount of time. I'm a little biased as a mechanical, but I will literally take any excuse to go and spend some time in this lab. It smells like coolant and grease, and there's always loud noises. And when I first came to CSU and I first toured this lab, I was, I guess, blown away by how many tools that they had and the size of everything. But then also when I took this lab for my first time as a sophomore, I was honestly a little terrified to turn on anything. You go into lecture and you learn about different manufacturing processes. And then for 3 hours a week, you go into the lab, and Doc, who runs the lab, will teach you how to use all the different tooling. And I was afraid to turn on the sander, and I asked him like 6 times if I could turn it on. And he said, yes, I've shown you how to do it. You are more than welcome to come in here. And once I've shown you how to do it, to get started working on it. And so this lab was really what I've loved so much about being a mechanical engineer. So here on this right picture, he's working on a vertical mill. And on the left is the CNC machine, which stands for Computer Numerical Controlled Machine. In this lab, you'll also have the opportunity to work on a lathe, which turns cylindrical pieces of stock, and you can turn them down to size. And you also actually have a CNC lathe, which can make more complex parts. It adds a whole nother axes of rotation. So you have your Z-axis, your X-axis, your Y-axis, and then because the lathe is spinning, the A-axis is the axis that spins parallel to the X travel distance or travel length. Sorry, I'm really geeking out. I love this lab, and I was in this lab for 4 hours this week working on some pieces for my research lab. And so something that I really enjoy about this lab is, one, the hands-on nature, but also the collaborative nature. And while you might think, oh, I'm working on my own projects, it's not that collaborative, the amount of support that I received from the mentors in this lab was immense. So I had picked up a handsaw maybe before coming in this lab. So working with these giant machines was a bit intimidating. And so I got really close with the lab assistant. His name is Ryan, and he would help me with all my projects, and I was super comfortable asking him questions. I just asked him, I sent him an email a few days ago on how to mount a specific piece. But on top of the mentors in the lab, there are also the students that really make a huge impact. One of the reasons that I chose CSU is just because of the family nature that I found here. I felt like everyone was really vying for my individual success, and that really held true in this lab specifically. You work with something called an oxyacetylene torch, which is basically acetylene and oxygen put together through a airstream, and then you light it on fire. They use it a lot in welding. And so these can get up to really high temperatures, and they're also pretty explosive. So I was really worried when I was first trying it out. And so there were 6 other people in the lab, and I asked literally all of them if they could walk me through how to set it up and make sure I don't like burn anything down. And so I'd never met these people before, but all of them were super willing to stop what they were doing and make sure that I was doing everything that I needed to safely and correctly. In addition to that, I can't tell you how many times I've asked other students if they could, show me how they how they worked on a part or what finishing process they used. And they would they'd say, hey, I have class right now, but if you have time, after hours, I'd love to come help. So I'd spend like 3 or 4 hours with someone just in their free time helping me out with my project. And so I actually have the first project that I made. This is the clock. And so this was milled out of a stock piece of aluminum on the vertical mill, which is on the right. And then this is a brass and steel pen and pencil holder that was milled on the lathe. And then this is just an acrylic base plate. But yeah, I really love this lab. And if you like getting your hands dirty and working with these big machines, definitely recommend checking it out. So this is our idea to product lab. So the EMEC is subtractive manufacturing, basically taking apart and reducing it by cutting off material. Additive manufacturing is just the opposite, starting with nothing, layer by layer, adding it on top of it. So this is a completely student-run lab. That has a bunch of 3D printers. And there is a lab fee because it is student-run. I want to say it's like $15 or $20, and you take a free course on Tuesdays in the library where they teach you how to use the 3D printers, how to slice it into acceptable G code for these 3D printers. And then you can print basically anything that you want, and you can reserve lab times for that. And so I used this last semester for a Mech 202 project where we made a bridge. The idea was to make a bridge out of plastic glue and string that could support 50 pounds at the midspan, so basically at the middle, and then not deflect by more than 0.1 inches. And so instead of doing like an I-beam, which was what we were supposed to do, and he told us on the first day as a hint, but he kind of disguised it. He didn't actually say this is the answer, but he gave us a homework problem on it. We decided to design a 3D print a whole beamed truss system. And so it worked. It just wasn't the most weight efficient, but it's a really great resource just because you have access to it basically all the time. So this is the materials lab. This is, you take it with Mech 341, which is just the materials. And so in that class, you learn about how different heat treatings can change the atomic structure of atoms. So you can have a mixture of copper and tin, for example, and the copper will get out of the tin at certain temperatures and create little, basically, if you think of, I don't know, like a pie. And so you have the juice of like the raspberry filling is going to be like copper, and then you have little raspberry chunks that are going to be like a tin, and so it'll precipitate out in different areas at different heat treatments. And so in this lab, you'll work with equipment that they use in industry to do testing and verification. So you'll do a stress analysis, so where you're pulling it apart and seeing how long it takes to break. You'll do torsional analysis where you're twisting it, bending analysis where you'll have compression on the bottom and then tension on the top of the beam, and do a lot of different mechanical tests on the material properties of certain materials based on how they've been heat treated, if they've been exposed to acids, and a variety of different processes. And then the Mechatronics Lab. So I'm actually in this lab right now. And so this is kind of a culmination of everything that you've learned up until your third year as mechanical engineering here at CSU. And so basically you take a fundamentals of electronics class your second year, and then your third year, you'll go into this class where you're taking those principles of electronics and applying them to building circuits. And so I have never really worked with circuits, so it's kind of still a big step up for me. But basically you get an Arduino kit with a bunch of different motors and servos and wires, and then an Arduino, and they'll walk you through a bunch of different labs where they'll teach you how to wire like transistors and all that stuff together so you don't blow up a circuit or anything. I'm sure Kylie is much better at it than I would be. And then also programming the Arduino so that you can make a servo rotate 180 degrees, make a motor spin, lots of different things there. I would definitely recommend, if you have any robotic experience coming into this class, it makes it 1,000 times easier. I did nothing. I always meant to learn about Arduinos, but then it never happened. And so the final project for this class is to make something that moves, that lights up, makes a noise, and has a visual output display, so like an LED screen or something like that. And so there are a lot of fun projects. One of my favorite projects is the Whack-A-Mole Professor, or Whack-A-Prof. And so it's basically a whack-a-mole game where the students in that group had the professors that they had at the time go into the idea to product lab. They used a 3D scanner to scan their faces and then 3D printed them. And then they made a whack-a-mole game out of the professor's heads. And a fun fact, the only professor's head that actually popped up was the professor of the mechatronics class. So it was pretty funny. And then there's also one, it's a it's a non-tilting drink cart. So basically it's a drink cart that holds drinks on the top. There's 2 wheels, and then no matter how you knock it or kick it around, the motors will auto level itself so it doesn't fall over. And there's actually a little remote control that can cart it around the house for you. And then moving into the thermal fluids labs, this is right below our BC infill, which we'll talk about more later in the tour. So this class is kind of an application of what you learned in your thermo class and your fluids class. So I took my thermo class about 2 years ago, and my fluids class I took last semester. And so this semester I'm actually in the thermo fluids labs. And so it's really nice being able to kind of take those principles that I learned in thermo and fluids and apply it to a real world setting. Wow. On the far left here, that dark green machine is a water tunnel. Basically, it's kind of like an air tunnel where you can place an object into it and then watch how water flows around the object. That light blue machine in the middle is a wind tunnel where same thing, but just with air, you can watch how the stream creates turbulence when flowing around an object. The yellow one is an oil pressure gauge. And so what you'll do is that tank in the back, at the top of the picture, holds oil and then shoots it through different diameter tubing at high pressures. And you measure how the pressure changes throughout the oil to determine a laminar and turbulent flow. And fun fact is I'm actually working on that lab this week. So I got to do the results section for that right after this. And then the dark blue machine on the right is a water testing apparatus where you can place an object. So for example, when you're designing piers, like you'll see in San Francisco to go out into the ocean, they have those pegs that go into the sand. You can make a scale model of that pier and then put that into this testing apparatus, and you can see how water will swell around the pegs so that you don't create any levees that could potentially create vortices that pick up sand and then dismount the posts. So yeah. And then over to Sammy for the Smash Lab.
Great, so mechanical engineers get to have all their fun in their materials lab, but I can test that civil engineers get to have more fun in their materials lab. And the technical term for this lab is the Civil Engineering Materials Lab, but it's way more fun to call it the SMASH Lab because that's really all we do. And one of civil engineers' favorite materials is concrete. That's why you see it everywhere. So this lab has a counterpart, which is the Concrete Materials Lab, which is right across the hall. And it goes hand in hand with your civil engineering materials lecture class, where you're learning about all the properties of concrete, how to make it. You learn what the difference between cement and concrete is, because I thought those things were the same for most of my life. And then you get to go into the lab and learn how to test and cast concrete. And then you also have the opportunity to get ACI certified. So ACI stands for the American Concrete Institute, which comes up with all the specifications for concrete and what the required strengths are and all those things. So you learn how to do like a bunch of different tests on this concrete and making sure it doesn't have like too many air bubbles, and making sure you're using the right kind of aggregate, which are like the little particles in your concrete, like sand or little rocks or pebbles or things like that. And then once it is cured, you can bring it into this lab and put it in a hydraulic compressor to see how much force it can take. And I don't know if you all watch those those satisfying videos on Snapchat stories or whatever that crush like a bowling ball or a birthday cake or whatever. We get to do that kind of thing with our concrete beams. And it's really fun to just see them crumble under thousands and thousands of pounds of pressure. The first day of class, we also got to smash a soda can, full versus empty. And it's just incredible to see the difference between how much more pressure a full soda can withstand because it's pressurized versus a tiny little empty soda can that you could just stomp on and break. And then in this photo, you see one of our tension machines. So another material that civil engineers love to work with is steel. So 2 of the big classes you'll take as a civil engineer, or I guess 3 of the big classes, are civil engineering materials, which covers concrete, steel, and wood, very introductory. And then you'll take a reinforced concrete design class, which kind of marries steel and concrete together, and then a steel design class. So steel is way stronger than concrete, especially it's really great for tension members. So that's what we're doing. Tension is pulling, compression is pushing. And so we're seeing how this piece of metal deforms. Also, like Ethan mentioned earlier, we do torsional testing on metal samples, and we do buckling testing on metal samples as well. So buckling, for example, there's a TV stand in my basement, and it has a wooden door with some really janky metal legs, and the piece of wood or the door is most definitely buckling. It has a huge like 90s TV on it, and so you can just see it kind of like going like this. So that's probably not a good thing. But we do all those types of tests in this lab, get to break things, we get to hear the pop, and it's really funny because it's a really open lab space. And like Ethan mentioned earlier, it is right underneath the Internet Cafe, which is a big lab space. So sometimes you hear a big crack or a snap or all these scary noises, and then people in the Internet Cafe just say, oh no, it's just those civil engineers breaking stuff. We also, I think the most satisfying sound that is heard in this lab is when we do bending tests on wood, because wood is another popular civil engineering material. So we put a huge beam in this bending machine and load it at the center and just crack it in half and learn about the different types of wood, engineered wood, and all about how it breaks along fault lines and why that is, and different like planes of stress and how they affect how it breaks. So it's a really fun lab, one of my favorites, and definitely is very satisfying. I'll just leave it at that.
Okay, fun. I think we're at our last department of the College of Engineering, so we're almost to the end. But this is the Department of Electrical and Computer Engineering, and unlike mechanical or civil, ECE labs don't have a lot of really big, fun, machines. And that's mainly because a lot of things that they do in lab is small enough to be able to be carried like in their backpack or something, or it's all simulated like on a computer, kind of an idea. But this is C105, and the lab right next to it is C107, and those two rooms are the only rooms for labs within the electrical and computer engineering department, and for like your 3 or 4 years in ECE. But I do kind of want to talk a little bit about like electrical engineering versus computer engineering, and then maybe even like electrical engineering versus mechanical engineering, because those are really common questions. So the way I like to describe electrical and computer engineering is if you put them on a spectrum, electrical engineering really focuses more on hardware development, circuit design. You can go into like the power industry, you could go into semiconductor industry. On the other end of the spectrum, you had like computer science, which is a lot of programming, algorithm-based writing, kind of telling a computer what you want it to do. And that really goes into more like software engineering. But right in the nice middle is computer engineering. And computer engineering really looks more at the culmination of where hardware meets software. And that's not to say that like electrical engineers don't code or don't do computer engineering or computer science topics, because they definitely do. But if you look at it more from like a curriculum base, electrical engineering students have something called SMEs, which are science math electives. So they get to pick between like computer science, math, physics, biology, chemistry, extracurricular classes, whereas computer engineering students will only take computer science classes as their like SMEs. Besides that, both of these majors also have pretty similar curriculum. If you're looking up until like your 3rd year, computer engineering and electrical engineering take the exact same ECE classes. But by the time that they get to like their 3rd year, it's a little bit more different. That being said, the difference between like electrical engineering and mechanical engineering, you're looking at electrical engineers for this lab, for example, are tasked in designing a line following robot. And the idea behind it is you'll build a circuit using a photoresistor, and a photoresistor is a resistor that changes resistance with light. So you'll use a photoresistor to follow like a black line on the ground. So you'll build that circuit and you'll connect that to a body of a robot, but that's like already assembled for you. Whereas in mechanical engineering, students will have almost the exact same problem in a lab or in a project or something, but rather than having to build the sensor, they're already given the sensor, and they just have to apply that to like the mechanical body of the robot. So putting the gears and the wheels together kind of a thing. So that's a really good example of like the difference and also similarities between electrical and mechanical engineering. And yeah, Goose, if you want to move on to the next slide. Awesome. And just to let you know, I think we are kind of getting close on time. So I'm going to try to wrap up at least all of the academic things by 5 o'clock. And if you can stay around for us to go over the rest of the things that we have for this tour, that's amazing. But if you have other plans or if you need to leave, that's also totally okay. This is a recorded session. That being said, if you have submitted any questions, we'll all collectively answer those questions together at the end of this presentation. Okay, so the next thing that I really like talking about is senior design. So senior design is a requirement of the College of Engineering. So all students within the college have to participate in the senior design project, which is like a capstone project. And these senior design projects can range in areas. So for example, this senior design project is actually an electrical and computer engineering project, but it's a biomedical engineering based project. So it's actually, this is a prototype of an MRI machine. So typically MRI machines are kind of like, and I only know this from like TV shows, so I could be really wrong. But I think in my brain, all I remember about MRI machine is that like they put you on a little conveyor belt and they like push you into this machine, and the machine starts like clicking by your ear, and it takes like tons of photos of your body, and then eventually all of those photos will be stitched together and to produce an MRI like image. But the hard part about that is that it's really long, and yeah, it's really long and kind of tedious. So this idea is obviously it's a very small demo of this MRI machine, but it's an MRI that's going to take one really high resolution photo due to the way that the conductive wires are looped around the person when they're put into the machine. And it's more of like an electrical engineering senior design problem. But that being said, you'll see a lot of senior design projects are interdisciplinary. So meaning you might have a mechanical engineering project, but you'll have electrical engineers, computer engineers, and maybe like a civil engineer on that same project with mechanical engineering students. So if you're looking to like kind of branch out, it's really nice to kind of, also there's a train going past me. So if you hear that, very sorry. Yep, okay. That being said, my senior design project currently, because I'm a senior right now, actually is a biomedical engineering project with an electrical and computer engineering application, which is really cool. It's a very brief explanation of it. It's in pharmaceutical testing, for example, there's something known as a well plate. It's basically a plate full of wells. And let's say you want to test if there's a drug that's supposed to cure cancer, you would put one cell into each well, put it into an incubator, leave it for 72 hours, and take it out and see how that drug affected the living cell. But the problem with that is the incubation period is so long that it extends this trial period for months and months and months. So what we did was we proposed a project that has live data acquisition. So there's a sensor at the bottom of every cell. And while the incubation period is currently going on, we're constantly getting data about like glucose, pH, oxygen levels, and it's being read into our system. So we have like a hardware team that's working on building the well plate with the sensors. We have a microfluidics team, which is looking at the sensor in itself, and the living environment of the cell. We have a software team, which is looking at building a GUI, which is a graphical user interface. That's how the researcher will get the information. So we have a lot of these different moving parts, and it's really interesting to kind of see how a mechanical and biological engineering student might start to work with an electrical or computer engineering student. So that's kind of my idea of like interdisciplinary projects. Awesome. Oops, next slide. Cool. And to kind of wrap up this ECE kind of portion, this is a picture of the Advanced Beam Lab in the Engineering Research Center. Goose kind of already talked about the research aspect offered at CSU. But a couple other things to add that I guess I could talk about would be like, typically, I think the most popular way of getting involved in research is definitely just like emailing a professor and asking them. And often at times that can turn into like a paid opportunity later on. But there's also HERS, which is the Honors Undergraduate Research Scholars, and that's like an application based process where you get invited to apply to this program, and if you're admitted, they'll pair you with a research area that is similar to your interests. You will have to participate in a showcase at the end of the semester or at the end of the year, and you'll also have to put in like so many hours a week to participate in this program as well. So besides like the unprofessional way of doing it, of just like emailing someone, there is more like structured routes to also be involved in research if that's also of your interest. Cool. Yay. Anyone want to take academic advising in office hours?
I can take that. Cool. So we talked a lot about the lab spaces, but if we were on an actual in-person tour and actually walking through the halls, we'd be walking by the advising offices for all these different majors. Each major has their own advising office. And I know that for civil engineers, we get to have a faculty advisor after our second year. But regardless of what your major is, you are going to have a super smart advisor who knows exactly what classes you take and exactly what order to take them in, so that you can get to your senior year and be at peace knowing that you have completed everything that you need in order to graduate. They're also there just for life advice to help you with careers and looking for internships and just to be friends with you. My advisor is like one of my favorite people ever. I would die for that man. He is the best. So they're just a really great person to go to with all of your questions, and you'll meet with them every semester to talk about how to craft your course schedule. This is another one of the study spaces in engineering. So even just looking in this photo, I know a couple of people in the room. So it's really funny going into these study spaces and knowing that you'll probably run into somebody that you know. There's kind of a brother space to this right across the hall that's called the Internet Cafe, that has a ton more computers and has a great view of the civil engineering materials lab and the fluids lab that we talked about earlier. But it's a really great place to come, again, to utilize those computers, utilize those printers, and hopefully run into somebody that you know that can help you with whatever you're working on. This is a picture of the Internet Cafe that I was talking about. Again, these pictures were taken pre-COVID, so now they have every other space is open. And again, you'll probably run into your friends. It's a really great place to be. It's called the Internet Cafe, and unfortunately there's not coffee involved, but I always bring my own, just a little pro tip there. And this is what your typical lecture style classroom will look like. So on the left, I believe that is, I would guess, materials with Bob Johnson. And the class on the right, I would guess that is either statics or dynamics with Dr. Baker, who I also love and would definitely take a bullet for. We have some really amazing professors. And these are some of your classes that you'll take probably in your first or your second year that are a little bit bigger. So people often ask about how big are your class sizes, and it's really like a huge funnel. So when you start your freshman year, you'll be taking really general classes that people inside your major and outside of it are taking. So chemistry, physics, math apply to various different majors across the university, not just engineering. And then in your second year, you'll probably be taking more fundamental engineering specific courses that you'll be taking with like mechanical engineers, civil engineers, environmental engineers all together. And that is kind of an example of what this classroom looks like. So those are a little bit smaller, but not by much. I'd say my first year classes topped out around 250 for general chemistry 1. And like my thermodynamics and solids and statics courses were probably around 150. And then later in your junior, senior year, you'll be in technical electives that are a lot smaller, probably around 30 people. So really the gist of this whole point is that as you get more specific, your class sizes get smaller. But I personally kind of like the large classrooms because sometimes if you're not really feeling it, you don't want to get called on, you sit in the back. Some days when you feel like being more engaged and getting to know your professor, you sit in the front. So it's more of a choose your own adventure kind of style that I definitely don't mind. All right, Ananya, I know that you lived in the engineering residential learning community. I'm going to put you on the spot and you can talk about it.
All right. So I personally love the engineering residential learning community. I know I recognize a lot of names on here from our session earlier today. So I apologize if a lot of this seems repetitive, but hopefully it just reiterates some of the information that we mentioned earlier today. So our engineering residential learning community is located in Academic Village in the Engineering Residence Hall, and I personally loved it. I have a lot of close friends that I met while living there, and you'll hear a lot of different perspectives about like whether you should live in that community or not live there. For example, I lived there. I really enjoyed the fact that anytime I wanted any sort of support for classwork, I could just go back to my room. I could walk down the hallway, get help from my neighbors, anything of that sort. But then I know Kylie lived in Allison Hall, and so that gave her a really nice break away from engineers once she was done with classes and stuff like that. So it really comes down to personal preference. But no matter where you live on campus, you can access all the resources located within the engineering residential learning community. And so if we go on to the next slide, we can talk through some of those as well. So one of my favorite resources was that on the first floor of that engineering residence hall, there's nightly tutoring from Sundays to Thursdays, and every single day is dedicated to a different engineering discipline. So in my case, chemical and biological engineering tutoring took place on Sundays. So my roommate, who was also doing the same major as me, would just accompany me downstairs. We'd get all of our engineering homework out of the way. So we also had general classes homework, but especially that first year, it gave us a lot of free time to just explore Fort Collins throughout the week. So that's something that was definitely really beneficial and just made it really nice to sort of go around and have more free time and not just focus on classes the whole time. And there's also a lot of collaborative study spaces in the first floor as well. And we also have design studios. So those design studios are similar to what we saw in the Scott Bioengineering building. So they have all the computers that you need with all the software for any of your classes. So whether that's MATLAB, SolidWorks, AutoCAD, whatever that looks like for your respective engineering discipline, you will find that software on a computer. So you don't have to worry about purchasing licenses or anything of that sort on your own personal computer. So that just saves a ton of money as well, which is pretty convenient. And then, so that's definitely a lot on the academic support resources part of it. And the tutors are students that have taken the classes before. So they just can give you really nice tips and tricks to successfully pass those courses. And if you don't understand something your professor says from a more technical standpoint, they can usually simplify things a lot for you as well. So that's just a really great way to get that exposure. And then moving on to the other side of it. So apart from the academics, if you go on to the next slide, we can then actually talk about the room spaces itself. So a lot of you might be wondering about the different sorts of types of rooms that we have on campus. So the two main different types that we have are either suite style or community style. And the main differences between those are that in community style, you're either living with a roommate or you might have a single room, and then the bathroom is a shared space for the entire hallway, and that's cleaned every single day. Versus if you're living in suite style, you have a bathroom in your room itself. So if you're in a suite style with a private bathroom, and it's a double room, then you just share your room with a roommate and you have your bathroom for yourself. That makes it really convenient, especially in your first year. If you have any 8 a.m.s like I did, you can definitely get up a lot later and just quickly walk to class. And so that's definitely something to consider. And Academic Village in general does have AC as well and heating. And so that just made it really nice for both the summer months and the winter months as well. But again, no matter where you live on campus, it really does depend on your personal preference, because regardless of where you live, you'll still be able to find that sense of community, and you'll still be able to access the resources within this engineering residential hall, no matter what. So that's just something to keep in mind. And you can definitely chat with any one of us, like one-on-one as well, if you're interested in more of our specific experiences living there as well. All right, and then this very last picture is just a picture of our room beds, and you can just loft them at any height you desire. So it's really a pretty customizable experience to whatever you want that experience to be like. And then with that, thank you for joining us for this tour. We can go ahead and answer any questions questions you might have. I know we had a question earlier, and Goose, maybe you might be able to answer this best. It asked, do you have a metal 3D printer?
I think I don't know if I feel like we may have just gotten one. So there's in the Idea to Product Lab, there's the regular just plastic ABS PETG printers that everyone can use, and then you can actually receive special training to use more complex printers that are kept in the back of the office. And I think that we do have a metal printer. I know for a fact that we have a carbon fiber printer that will print with carbon fiber, and then we also have a clay printer, I think. But yeah, sorry, I can't really see the chats because my screen is sharing, but.
Oh, that's okay. That was just a chat I noticed earlier on when we were going over the 3D printing lab. We had another question about where's aerospace, and our student ambassador, Katie, answered that in the chat. So we don't necessarily have an aerospace engineering major itself, but we have an aerospace concentration. So you would go into mechanical engineering and then declare that concentration later on throughout your academic career. And the reason we do that is because while aerospace engineering is definitely a very broad-based topic as well, a lot of the fundamental concepts within it lie in mechanical engineering. And I'm sure Goose would be able to answer this much better, but a lot of the concepts that you learn from aerospace are start off in mechanical engineering. So mechanical engineering really allows you to start off that foundation, and then you can specialize in aerospace, because we have these classes that you usually take in your upper year levels, so aeronautics, things like that, that really allow you to specialize in that specific field. Goose, do you want to add on to that?
Right, so like Ananya was saying, and kind of similar to why we have that biomedical engineering dual degree program, the depth that you get from kind of these core engineering, so mechanical in this example, is really essential, I guess, or it's very technical. And so it's a lot easier to take those technical applications and apply it to an aerospace field. So any dynamics that I do as a mechanical engineer, I can apply to a frame for a wing, for example. But if you kind of focus on just doing an aerospace major, you're kind of just limiting yourself to just those aerospace ideas. And so you don't have that depth that you get from having that main mechanical engineering with an aerospace concentration. And so one of my friends just received an offer for Lockheed Martin. And so she is actually the project head for the CSU rocket team. And so she's taken a lot of just aerospace classes, or I guess technical electives. So she took something like controls, which is a lot of, actually, I'm not 100% sure what it's even about, but it's called controls. It's an aerospace class. She's currently in a liquid propellant class where she's learning how to design different liquid propellants and how to integrate that into a rocket for different thrust vectoring. And so she really has enjoyed the program so far. And then we actually had a student ambassador. Her name was Danelle. She graduated last semester, and she did a co-op with NASA and is actually an engineer with NASA currently in Florida. So that was really cool to hear about her experiences. But yeah. Also, something funny that Kylie mentioned, just that, all the projects can fit in the back pocket for electricals. That's 100% true. I'm in the mechatronics, and so that's a lot of electronics stuff. And so I have this little tiny box that I can keep all my motors and my breadboard and all my Arduino kits in. But when I was taking the manufacturing class, I would literally have like 20 pounds of raw stock with me in my backpack going to lab, or just like at 8 a.m. when I had to work on like 3 different parts that day. And so it's just really, that was just funny.
Thanks for sharing this. And yes, to answer the question, in Sweet Living, does each roommate have a desk? Yes. So every single roommate gets their own desk, and the closet is like a shared space, but you have a lot of room to put your clothes and things like that over there as well. And the vanity is not located, like the sink and the vanity area isn't located in the bathroom itself. So that just makes it really convenient to, again, rush out the door. Like if your roommate's showering, you don't have to worry about their schedule before you're leaving or anything like that.
Pro tip for the rooms, through the engineering technology services, you can actually request to have a desktop set up in your room. I didn't know that until I have like 6 friends that work at ETS now, engineering technology services. And so you can just request to have your own desktop in your room that has all the software and the virtual classroom set up so that you can just wait instead of having to go into a lab or going downstairs or find an engineering lab, you can just do it in your room. So definitely should have done that freshman year.
And yes, you mini fridges are not included in the rooms to answer your question, Todd. I would definitely recommend bringing your own. You can also bring your own microwave. The one thing they don't let you have is toasters, I'm pretty sure, or like water heaters. I'm not exactly sure why that's where the line is drawn. Don't bring water heater or toaster, but do bring microwave and mini fridge. If you can't bring a microwave or a mini fridge, there is also a kitchen in every single residence hall. So you can just go to the first floor, label your food and keep it in there. And that also has like oven, microwave, all the other appliances that you might need.
Yes. The campus also offers like a microwave refrigerator combo like rental. So that's what me and my roommate did my freshman year. And that was so convenient just because it was already there in your room when you got there and you just had to leave it in your room when you left. So there was no like dragging something into your room that's really heavy, especially when you live in Allison and there's no elevator and so someone who like lives on the third floor would have to like drag that like upstairs, and that would kind of suck.
Great questions. Are there any more last minute questions? We can hang out for a little bit longer. Just throw them in the chat. If there aren't any questions, then we can go ahead and wrap it up. I really hope that you enjoyed Engineering Exploration Week. This is the last session that we're offering for the week. So I hope that you got to attend some really informative sessions, got to know a lot of students and hear about our experiences, because I know that that was kind of the thing that tipped the scales for me to choose CSU, just because I heard about how passionate everybody that went here was and everybody loved it. And I thought, oh, maybe I could love it too. And I definitely do. And here I am, hopefully passing the torch on to the next generation of CSU Rams. So please keep in touch with us as you're making your college decision. I'll throw the ambassador email in the chat, and you can always reach out to us that way. We're happy to answer any questions that you have, especially as you start to sign up for like orientation, or maybe you have questions about filling out scholarship applications or anything like that. We're definitely here to help you out. You can't type and talk at the same time. Explore at engr.colostate.edu. Boom, there it is. Please reach out to us. We have tons of other opportunities for you to connect with us virtually. Like you can set up a one-on-one appointment just to talk with one of us, kind of face-to-face online for like half an hour to an hour, and just get those questions, like knock them out. And we'll have more like webinars and stuff. But if you went to this event, you've probably compiled a lot of information and have a lot to think about. So I hope you had a great time, and thank you so much for coming.
Yeah, thanks for joining, everyone.
Thanks, guys, everybody.
Yay!